Hello, and we're going to learn today nodal analysis. And the very first thing you need to know is what is node. Node is the combination of two or more elements, and by elements I mean resistance or any type of voltage or current sources. And node can be of two types: a simple node and a principal node. A simple node is when two resistance or two elements are connected like this. This is known as simple node. Where current division does not takes place, it is known as simple node. And principal node is a node where current division does takes place. Like if we draw this circuit like this and we add another resistance over here, this type of circuit having more than two resistance or two elements are known as principal nodes. Now, to solve nodal analysis problems, we will only consider the principal nodes. This is something you need to keep in mind. Let's observe this diagram for once and let us try to find out the number of nodes which is available over here. Now, if you look over here, you can see one resistance, two resistance and a source are connected at this point. So this is a node. Over here you can see this resistance and another resistance over here, they are connected, so this is a node. Likewise, this is also a node. Over here these three elements are connected, so this is a node. These three elements are also connected, so this is another principal node. Again, these three are connected, this will be a node. And if you notice over here, 1 2 3 4, these four elements are joined together over here, so this will be another node. Obviously you can see this resistance and this source are connected in series. This is a simple node, but we will only consider principal node for nodal analysis. Now let us learn the 5 steps that you need to do in order to solve any type of nodal analysis problem. And the first step is to you need to identify total number of nodes. You have to identify the total number of principal nodes that are present within the circuit, like the one we have done over here. As you can see, there are 1 2 3 4 5 and 6 and lastly 7 nodes over here. The next step is to assign nodal voltage at each node and a reference node. There will be a reference node. And what does it mean? Well, the first thing is you need to assign nodal voltages, so which is very simple. Let us assign V1 voltage over here, V2 voltage over here, V2 voltage, V3 voltage over here, V4 voltage, V5 voltage, V6 voltage, and this one will be V7 voltage. Okay, and the reference node is that we have to consider any node within the circuit, and that node will have a voltage value of 0. Okay, that node will be grounded, and it is wise to select a node that has maximum amount of branches connected to it. Like this node, there are 4 branches connected, so we will consider this node, the V7th node, as reference node. That is, the value of V7 will be 0. This node will be grounded. Next step is to develop a KCL equation for each non-reference node. That is, we will apply Kirchhoff current law. And the fourth step is to solve the KCL of Kirchhoff current law equations. And the last and final step is to perform calculation as per question asked. Now let us discuss this simple basic concept. Let us consider I amount of current is flowing through this circuit, where R is the resistance, V is a source, Vx and Vy are 2-point sources. And we all know the definition of current is basically voltage by resistance, and voltage is basically the difference between the 2 points, that is voltage V high and voltage V low. So based on the basic concept of current and applying over here, we can write like this: voltage high, since current is flowing in this direction, Vx will be higher than Vy, so we will write Vx minus Vy by R. But hold on a second, because there is another source V over here. Since current is going out from the negative terminal, remember this, since current is going out from the negative terminal, we will write minus V. Remember this simple technique, because it will be very useful for you when you try to solve future problems. Now let's try to solve this nodal analysis problem, and the question says that you have to find I, and we are going to solve this equation, this circuit, using nodal analysis. And if you remember these steps, the very first step was to identify total number of principal nodes. So let us say, as per the diagram, this one is a node and this one is another principal node. There are only two nodes over here. Step 2 is to assign voltage at each node. So we will assign voltage V. We'll say this one is Vx, this one is Vx, and this one will be another voltage, and this one we will consider this as the reference node. So voltage across this point will be 0. The third step is to develop KCL equation on each non-reference node, and by non-reference node I mean this node only. There are only one non-reference node over here, so we will develop a KCL equation on each node. And we will also consider another thing. We will consider all currents are going out. That is, we'll consider, let's say I1 current is going out from this node, this branch. We will consider I current going out from this branch already given, and we consider I2, let's say this as I2 current is going out from this branch, and applying KCL at node 1, we can say I1 plus I2, not I2, sorry, I1 plus I plus I2 will be 0. The fourth step is to solve KCL equation to get nodal voltages, and for I1 we can write, as we have already discussed, I1 can be written like this. I1 will be Vx, the potential difference across these two branches, Vx minus 0, since that is 0, Vx minus 0 within bracket, then since current is going out from minus 4, so we write minus 4 whole divided by resistance R1, which is 1 ohm. And for I, we can write again similarly Vx minus 0 within bracket, and I is going out from minus 2 volts, so minus 2, and everything is divided by again R2, which is 1 ohm. And I2 is basically minus 2 ampere. 2 ampere source current is going upward, and we have considered that node currents are going out, so we can say simply minus 2 is equals to 0. Solving this equation, you will get Vx will be equal to 4. I'm not going to show you how to solve it. This is basic algebraic equation. The last and the final step is to perform calculation as per requirement, and the question asked us to find the value of I. They want us to find the value of I, and using this previous concept, we can say I is basically Vx minus 0 by I is basically Vx minus 0. I'm not going to write 0 again, minus 0 minus 2 by resistance, which is 1. So Vx is 4 minus 2 will by 1, so I is 2 ampere. I is 2 ampere. This is how you solve every type of nodal analysis problem. Now, what you're seeing here is a problem for you. The question says you need to obtain nodal voltages in the circuit. Okay, so apply, and you have to solve this using Kirchhoff current law or nodal analysis, and you have to find the voltage over here, what will be the voltage in V1 and voltage in V2. Try to solve this on your own using the concept that you have learned just now, and if you find any problem, do let me know. With that being said, thank you very much for your time. I hope this was helpful. Goodbye and take care.